Ever wondered how AI models like ChatGPT or Gemini get better at solving problems? It's not just about memorizing facts, it's about learning through feedback. Today, we're diving into a groundbreaking study that's reshaping how we think about training AI to reason across different fields. Most research on reinforcement learning, RL, for AI has focused on math and coding, domains where answers are clear-cut and easy to verify. But what about logic puzzles, scientific reasoning, or even data analysis? These are crucial skills, yet they've been largely overlooked. The problem: RL needs reliable feedback signals to work, and those are hard to come by in complex or less studied areas. Imagine teaching a dog to fetch a ball. You reward it when it gets the ball right. But what if the task is more abstract, like solving a riddle? The reward isn't as obvious. For AI, this means training data needs to be carefully curated, free of duplicates, balanced in difficulty, and tied to clear goals. That's where this new project called Guru steps in. Guru is a massive, hand-picked dataset of 92,000 examples spanning 6 domains: math, code, science, logic, simulation, and tabular data like spreadsheets. Each category was built with special care. Domain experts designed reward systems, filtered out messy data, and made sure the examples were both reliable and challenging. It's like creating a library of puzzles, each with its own rules for what counts as a correct answer. Here's where it gets fascinating. The researchers tested how well RL improved AI models across these domains. They found that models trained on math, code, or science, areas they'd seen a lot during their initial training, benefited from cross-domain learning. Think of it like a chef using cooking skills to bake a cake. The basics transfer. But for domains like logic or simulation, where the AI had less prior exposure, it needed in-domain training, like learning to bake from scratch instead of just following a recipe. This suggests RL isn't just about refining existing knowledge, it's about teaching new skills. The team also released 2 models, Guru B and Guru 32B, which outperformed existing open-source models by up to 7.9% on complex tasks. And here's the kicker. These models improved their ability to solve problems that weren't even in their training data, like tackling brand new scientific questions or analyzing unfamiliar datasets. Let's unpack the method. The team used a dataset called Guru, packed with problems from 285 disciplines, including those tricky zebra-style logic puzzles. They trained models using reinforcement learning, where the AI gets rewards for correct steps. Think of it as a teacher giving a gold star for each right move. But here's the catch: solving these puzzles isn't just about speed. It's about pattern recognition and systematic thinking. For example, a model might start by eliminating impossible options, then piece together clues like a detective. What did they find? The larger Guru model, 32B parameters, crushed the zebra puzzles, scoring over 54% on average, way ahead of other models. But the real win: it didn't just memorize answers. When faced with new, unseen puzzles, it adapted. Why? Because the mixed domain training taught it to generalize. It's like a musician who learns jazz and classical. They can play anything. This study isn't just about puzzles. It shows that AI's reasoning skills improve when it's exposed to a variety of challenges. Imagine an AI that can debug code, analyze scientific data, and solve logic problems, all because it's learned to think across disciplines, not just regurgitate facts. So what's next? Researchers are refining these methods, making AI even better at tackling real-world problems. The takeaway: the future of AI isn't about narrow expertise. It's about building systems that can reason, adapt, and solve any puzzle life throws at them. Thanks for watching. If you want to see how AI tackles these puzzles step by step, hit subscribe and stay tuned. Until next time, keep exploring the frontier of AI reasoning.